Now, I want to be real with all of you.
There's the voice.
We want to make sure that we are trustworthy. That means things that we say should be the truth and not things that are false.
Like I did my work on
Like your work or the things that you said. You're not excited because you know that dividing a polynomial by a polynomial means we have to deal with this. Long division. And I know what you guys are thinking. What in the world is going on here? Long division. Yeah, draw it. If you don't put this in your notes, then I mean.
Do it, Harry.
Question.
Yeah, instead of me writing the question mark or saying what's going on here, I can just draw a silly little face, right? No, you'll find out what WTF means in 0310. Whiskey Tango Foxtrot. Now, although I don't understand Whiskey Tango, so you get drunk and then you do two dances, right? So when I have this long division, excuse me, when we have this long division, do you know how to do long division? Please tell me you do. Okay, don't tell me you know how to do it. Just forget it. I didn't even ask you. You would say 12 goes into, well, it doesn't go into 2, but it goes into 29. How many times?
2.
So you put the 2 up here, and then what do you do with that 2? I multiply that 2 times what?
12. 2 times 12.
That 12, which is called the divisor. So what's 2 times 12?
24.
And then you do what? Now, a lot of times you guys cheap out on me. You don't actually put the subtraction, do you? You should. So then 29 minus 24 is 5. You just kind of keep going on after that, right?
Yeah.
I'm going to put a pause in this for just a moment because I want us to see what we're doing here and compare it to having this problem here. I need to talk to the school about providing, barf bags to have next to your desk or in the seat back in front of you. When you see, it's fraction. Now, when I do this long division, we're going to focus on this x right here. Okay? He's not the end-all, be-all. He's just kind of a helper for us. And I can't really say how many times does this go into the polynomial. That's not going to make a lot of sense to us. What we're going to do is try to figure out what can I multiply x times to get x squared. You'd multiply x times x to get x squared, right? Now notice that over here with the 2, you multiply 2 times the entire divisor of 12, right? Likewise, you're going to multiply the x times the whole divisor here, which is x plus 3. What's x times x plus 3? It's x squared plus 3x, right? Now, if you guys have ever watched infomercials, if I were to say, you said it, and forget it. You guys don't remember the rotisserie thing, the Ronco, you know?
What, QVC channel?
No, it was just, never mind. No one watches info. It's okay. Those have some kind of catchphrase, and they say part of it, and then the audience says the rest of it, and it gets stuck in your head, which obviously worked for me. What we're going to do is we're going to draw the line and change the sign. Okay? So when I draw the line like I did here, and I'm going to change the sign. That's the subtraction part. We said that when we subtract, we add the opposite. So that's why we change the sign. Okay? So we're going to change the sign here. Now notice what I'm doing is I'm changing the sign and I'm highlighting what my new sign is. So it's now a negative x squared, and this guy is going to become what? A negative 3x. Okay? Now, the x squares cancel, and that's exactly what we wanted to have here. Then you just finish this. 7x minus 3x is what? That's 4x. Now we're going to pause. And we're going to go back to the original long division problem that we had, and we're going to finish it just the way we're supposed to. Now over here, we would bring down the 3, so we have 53, and then we start all over again, right? We see how many times does 12 go into 53? And what would you say?
4.
It goes in 4 times. And again, you take that number up here times your divisor. And what's 4 times 12? 48, that's right. And so I'm going to put the 48 here, and then I'm going to take a different colored pen. I'm going to draw the line and change the sign. So that's my subtraction. And we've got 53 minus 48, and we end up with what?
Well, why are you saying change the sign? Well, we've always been used to subtracting to begin with.
Because when I say subtract over here, a lot of times students only put the subtraction in the first term, and they don't actually subtract the whole polynomial like they're supposed to.
Okay.
So we have something that's kind of catchy. Draw the line and... Okay, you know what? If you want to be YouTube sensations, you have to make sure that you respond appropriately. Let's try this again. So we draw the line and...
Change the sign to negative.
But, you just change this. Okay, well, if it starts positive, it becomes negative. But if it started out as a negative and you change the sign, it becomes positive. So you can't always just change the sign to negative. No, you change the sign. Now, I end up with 5, which is a remainder. Don't worry about it. Remainders are okay. Are you with me?
Yeah.
We're going to come back to this in just a moment. Let's finish this guy. I'm going to bring down the 10 just like I brought down the 3 over here. See the analogy? See the comparison? Now, x, no changing sign here. That's why I have a different colored pen here. I can always say hello to my little pen. Now, x times what gives me 4x? A positive 4, right? Because see, you want it to start off looking exactly the same as the 4x so that when I change the signs, they become opposites and they go away. 4 times x is 4x. 4 times 3 is 12. It's about to be your turn. Now I'm going to draw the line and
Change the sign.
no one will buy my product if you react that way. So change your sign, change your sign. The 4x's cancel, perfect. What's my remainder here?
Negative 2.
Over x.
It's negative 2. Now, this is the work that I'm doing for the long division. But we have to find a way to write our answer precisely. Now, if I look at this guy right here, if I were to say 293 divided by 12, how many whole times did 12 go into that? 24, but how would you finish this off? Writing it as a mixed number.
12.
You take the remainder over the divisor. Do y'all agree? And I know we may have forgotten this. Even though these guys are right next to each other, and oftentimes that means multiplication, with mixed numbers it doesn't. This actually means addition. So this means 24 whole pieces plus 5/12 of another thing, right? But look what I have here. This is my... That's not... Why did I write that? Pretend I didn't write that. Edit that out. The 24 is your quotient. This other part is your remainder over your divisor. That's how I'm going to write this guy. That's how we write our answers for long division. So if I'm doing that over here, what's my quotient? My quotient is x plus 4 plus, what's my remainder? Negative 2 over what I was dividing by, which is x plus 3. Okay. We see the connection that we made with long division, how we go from a fraction to a mixed number. It's the same thing over here. When I do long division, you've got your quotient, that's the whole number of times it goes in there, and you got your remainder over your divisor.
Why can't we just set it up like we've done all the other ones? Like mono over mono or polynomial
Well,
over mono? I mean,
because what were you dividing by? In the other videos that we were doing, we had a monomial divided by a monomial. We had a polynomial divided by what? A monomial. When we're just dividing by a single term, life is easy and life is grand. But when we're dividing by something that's more complicated, that has more than one term, like this guy right here has 2 terms, we must use long division right now. There's no other way of doing that division. I mean, at least for right now, what we're talking about. And there's another way of doing it when you divide by something like x plus 3, but we're not going to talk about that right now.
So that's the final answer.
Right now, I want to talk to you about how we go about checking your work. Okay. If you were to check your work, how would you check that 293 divided by 12 is all of this? How do you check that?
Give more.
You do 24 times 12 plus 5, and that should equal 293, right?
Mm-hmm.
When you do this work, that's 288 plus 5, and that does equal 293, so that checks out. Do y'all agree? The same thing should work over here. If I multiply so over here I did my divisor by my quotient. So if I do x plus 3 times my quotient of x plus 4, and I add back in my remainder term, I should get back to my original dividend, the guy that was inside the division problem. So when I FOIL, I get x squared plus 4x plus 3x plus 12, and then of course I have to take off that 2. Does that get back to where I started? That's x squared, that's 7x, and that's plus 10, so everything checks out. Okay. You check it just like you would have checked long division back in the day.